Objective number 2, construct and interpret confidence intervals for the population variance and standard deviation. The sample variance is the best point estimate of the population variance. We use the sample standard deviation S as the point estimate of the population standard deviation. Now, it is common practice to use S as the estimator of the population standard deviation, even though the S is a biased estimator of the population standard deviation. Now, we now develop a method for constructing a confidence interval for the population variance. And so suppose we take a simple random sample of size n from a population that is normally distributed with a mean and standard deviation. Then the following formula follows a chi-square distribution with n-1 degrees of freedom. And therefore, 1 minus alpha times 100% of the values of chi-square will lie between a chi-square value of 1 minus alpha divided by 2 and chi-square alpha divided by 2. And in figure 21 is going to illustrate this situation. So 1 minus alpha times 100% of the values of this formula lie within the interval defined by the following inequality. So this is in the middle of the inequality, n-1 times the variance, the sample variance over the population variance. And it's going to be in between those two values, where this value over here is the smaller of the critical value, and on this side, this is the larger of the critical value. Now, if we rewrite this inequality with the variance in the center, then we have the formula for 1 minus alpha times 100% confidence interval for the following. We're going to have n-1 times the sample variance over the critical value on the right. And on the right-hand side, it's going to be n-1 times the sample variance over the critical value on the left. So figure 21 shows this. So here we have 1 minus alpha times 100% of the values of n-1 over the sample variance divided by the population variance, which is going to lie in this beige region. And so in this region here, this is alpha divided by 2. So you're going to take alpha divided by 2, and therefore this is going to be the left critical value, which is 1 minus alpha divided by 2. And then on the right side, we have the area of alpha divided by 2, so this is going to be the right critical value. So a 1 minus alpha times 100% confidence interval about the population variance. And a simple random sample of size n is taken from a normal population with mean and standard deviation. Then a 1 minus alpha times 100% confidence interval about the population variance is given by the following. So the lower bound is going to be n-1 times the variance, or the sample variance, or the sample standard deviation squared over the critical value on the right, or the chi-square critical value on the right. The upper bound is going to be n-1 times the sample standard deviation squared over the critical value on the left, where the critical values are found using n-1 degrees of freedom. Now, to find a confidence interval about the population standard deviation, you would take the square root of the lower bound and the upper bound. The method for constructing a confidence interval for a population variance requires that the data come from a normal distribution. Confidence intervals for the population variance or standard deviation are not robust. Therefore, if the requirement of normality is not satisfied, do not use the methods presented.